So there's three parts of owning a laser. You've got somebody that's a designer, you have somebody that's a programmer, and you have somebody that's the operator. The operator is typically the programmer as well, at times, but neither one of them are the designer. The designer needs to understand how everything is going to work on the end, and not just doing the frontline design.
Absolutely. One of the goals today is we're going to showcase exactly what a designer, what an operator, what a programmer are going to have to go through to really make these machines sing. We're going to talk about tab and slot technology. We're going to talk about how it gets designed, how to compensate for that cut in the programming, and then as the operator, how to cut it and bend it so that you get the most pristine results that you're looking for. It's one thing to have this equipment, it's another thing to make it sing. Today we're going to teach you how to do all of it. Hey guys, Steve Carroll here with Snake River Manufacturing. We are on location today at Smoke Ranch CNC out of Boise, Idaho. Today we're going to be doing some filming, talking about tab and slot technology and how to make their CNC lasers be able to cut effectively whenever you're putting two sheet metal parts together. We use that quite extensively when we build our metal fenders. To show you how that works, we're going to take a look at SolidWorks. So what we see here is we have two sheet metal components. We have a 14 gauge channel on top. We have a 14 gauge channel on bottom. We don't want to mess around with locating this as we're welding them together, so we want to utilize tabs and slots, which will help locate this part on top of that part consistently. To do so, what we're going to do is we're going to right click on the part we want to add tabs to. So we're going to edit this part in place. You'll find that here under the edit part button. Let's go ahead and click that. And now you'll see our assembly is just focusing on the part that we're editing. From here, we're going to click up to the sheet metal tab, which we're already in. And on the sheet metal tab, we're going to find the thing called tab and slot. Go ahead and click that. When we click that, we get a dialog box over here on the left-hand side, and it's asking for the group. We're going to link our groups together as well. So the first feature, or the first thing that it's looking for, is the edge of the part that you want to tab. So in this case, we want to join this line right there with the tab. The second thing that it's asking for is the opposite face. So you need to click the opposite face, right? So that's where we want our tab to go through to. Over here, you can change your spacing length, or your center of line. This is your spacing area. We can change the quantity of tabs, say 2 or 3, and then you can specify how wide or how narrow you want those. In this example, we're just going to have one tab, and you can see him in context here, where he's coming off the bottom of the part and going through the top of the other part. Down here, we can specify the width of the tab, or the length of the tab, and the height of the tab is going up to surface. You can change that height to say blind and specify the length or an offset from the surface. In this case, we're just going to select up to surface. Now this is really important. The slot gap right over here, we're going to do normal cut, and we're going to set our clearance, this is the space between the tab and the slot, to 0.01 inches. You can increase that or decrease that depending on your parameters. In this case, 0.01 is a good clearance. We're going to go ahead and hit OK and accept. So when we hit OK and accept, you'll see that in the context of the assembly, the slot has automatically been created in the adjacent part. So now that that slot has been added, we can close the Edit Assembly button, or Edit the Part button. And let's go in and take a look. We can see our tab going through our part right here. We can also see our tab here. If we open up this part and rotate it around, you'll see the tab. If we tab back over to our assembly and open up the bottom part, we'll see our slot. Perfect. Now a really useful tool is if you have configurations where it may be possible for this top part to get installed backwards is to install tabs and slots on different flanges of different thicknesses. And that's going to only allow that part to fit into the bottom part one specific way. So let's go in, let's take another look at this tab here on this other side. We're going to go ahead and edit in context, right? Edit that part. And we're going to use our sheet metal tab, and we're going to click tab and slot. Now we're going to add a different set of different set of tabs and slots with a different pattern on this side, and that's going to guarantee that this part can only be installed in one specific way on this base plate. So we're going to edit this flange here. We're going to add a couple of tabs. So we're going to edit this part, right click right here, come up, click edit part, and now we see we don't have tabs. We're going to add those tabs. So we're going to go up to the sheet metal tab up here, click it. We're going to go over to our tab and slot. We're going to click that. It's going to throw us back into our tab and slot prompt. And we're going to select this edge right here for our new series of tabs. In this case, we want 2 tabs. We're going to leave those at equal spacing. I'm going to scroll down. We do want the length of this tab to be 3/8 and the up to surface. So on the up to surface, we've selected face 1, which is the opposite face, which is where you want that tab to finish. This guy right here. Everything looks good. Oh, actually, before we do it, let's make sure that our clearance between our tab and slot is right where we want it, 0.01 inches. That looks good. So we'll go up and check that box. We're going to exit out of edit part, and we're back in the context of our assembly. So that's a really quick down and dirty overview of tab and slot design on SolidWorks. Now we're going to go cut out some parts that are utilizing the tab and slot technology and show you how close of a clearance this actually is. It really helps putting assemblies together, especially of the sheet metal type. So what we're going to do is we have a test coupon. It's 40 millimeters by 100 millimeters with a 20 millimeter hole. We got our 14 gauge loaded up and our coupon set for 14 gauge as well. We're going to make sure we've got the right nozzle, check capacitance, cut this coupon, measure, and do our compensate values from there. Let's get started. 2.0 single, perfect. Now that we've got our tip change done, we need to set capacitance for this particular sheet. So now we need to set capacitance. We're going to navigate to our CNC tab. We're going to go over to this button right here, BCS 100. Click the drop down and come down. We're going to click calibrate, and we're going to use auto calibrate. What that's going to do once we click it is it's going to give us a warning. Let's go ahead and bring this warning up here so we can see it. It says calibrate at current position. Confirm calibration motion is safe, then start. You need to make sure that there is material underneath the laser head before you do this, otherwise you will drive the laser head into the table. Yes. And now we're measuring capacitance. Now that calibration has succeeded, we've got our new capacitance curve. Go ahead, check OK. Now we're ready to begin cutting our coupon. So what I'm doing here is I'm getting the coupon set at the very corner of the sheet. We'll make sure that our outline is correct and we're not cutting off the plate by hitting the frame button on the controller. You hit the frame button and it gives you an outline of what you're about to cut out. Okay, now we're ready to cut our first coupon. We're going to go ahead and hit start, cut this thing out. grabbed our freshly cut coupon. Now we need to take some calipers to it and measure the ODs and the IDs, and that's what's going to give us our compensate value. Okay, so we've got our calipers. We're looking for 40 millimeter on the width. We are at 39.69 on the width. So what we need to do is we're targeting 40 millimeters. We're going to subtract 39.69 millimeters from 40 and then divide that result by 2, and that'll be our compensate width for the outer. .155 millimeter. On the Home tab, you have a Compensate button. Click Compensate, and for the outer width, we're going to put in that number of .155. We need to measure the inner and do the same thing. We divided that number by 2 because that's what's happening on all sides of the part. So you got 2 sides on the width, same thing on the interior. Divide that number by 2. .23, and we're shooting for 20. So we need to take half of .23. .115. That's our inner compensate value. .115. Inner width there, outer width there, and we want the inner to shrink. We want the outer to expand because we were skinny on the outer and we were wide on the inner. So we'll check that, hit OK. Now with those compensate values selected, we can cut our second coupon and confirm if our compensate values are correct. Pull out our calipers. Look at that. Perfect. So we got our outer width correct. Now we're going to do our inner. So we're right there at perfect with our outer and our interior. Now we can go ahead and cut all of our programs. If we don't set the compensate values, because we set our precision so low on the tab and slot, we want to make sure that those clearances and as well as our pattern files are exactly perfect, because everything else is going to be based off of that. Our backstops with our CNCs, our tabs and slot clearances. Perfect practice makes perfect. Now we've got our parts already nested. We're going to go ahead and hit start, run this machine. We'll do a time lapse to show you how everything cuts. So this 14 gauge sheet, which is .070 inches, took about 4 minutes to process. Now when we programmed it, we didn't utilize smooth micro joints, which would have prevented the part negatives from tipping up. We hit pause on that and knocked those out of the way, so we didn't actually get a tip touch. And that's really important. As a CNC programmer, you want to make sure that you're not putting your operator in a position where he has to babysit the machine. Smooth micro joints are the solution to what we just witnessed today. We'll talk about smooth micro joints in another video. So what we're showing here, that's our tab, and it's going to fit perfectly into these slots. After everything is formed up, now we have a locating feature that's going to guarantee that this part is always aligned in that slot right there. So using tab and slot design for sheet metal with your laser will greatly improve your production flows, reducing your bottom line, putting more money back into your pocket. Take full advantage of SolidWorks and the integrated tab and slot tools, and utilize Smoke Ranch CNC for your laser solutions.